Alright, so hello everybody. What's up? It's Pop Bale, and we're just working with the impossible right now. And we're not getting very far, but we are getting somewhere. And that is our multimeter reading at this speed. There's no power going in, but I've rerouted the power from the bridge rectifier back into the transistor of the drive. So we'll see how long it spins like this for. It's just a pulse motor, really. Kind of a transformer. We got a lot of generator coils and just one drive coil. But as you can see, I've got the bridge rectifier from the generator hooked back into the drive, and that is the voltage going through the bridge rectifier. Slowly dwindling, but as you can see, it'll increase every so often. Hell yeah, man. When you realize that space is the thing that's moving, you can do warp transportation in warp speed. Yeah, man, you can do it all while you're moving really fast. Does it look like it? I'm just curious. We're going to see how long it spins at this speed for, just for a little while. It's going to spin forever, but I mean, no, I'm just kidding. As you can see, the small amount of voltage is slightly increasing every once in a while, and that's because of how I got this set up. So like every 3/4 of a turn, you'll get 3 or 4 hundredths of a volt. Oh, yeah, we could push it, or I could turn it on, either way. Oh, it's like kind of right there at the 6 where it's trading off. So that's like not really a good spot for it. It's putting a lot of tax on my multimeter. I'm gonna turn it up a little bit. Give it like 3.5 volts. That's got a nice pulse to it. You can hear that. Or I can hear it. I don't know if the mic's picking that up. That's a 14-inch rotor. It's got 12 neodymium magnets on it that are 40 by 20 millimeters. In the middle, yes. Duct tape, but I taped them on there so they wouldn't fly off. This is 3.5 volts in. Yeah, I don't need it to spin faster. Besides, I can get it spinning way faster than a drill just by putting 5 volts in. Just give it a second. There goes the table. See, it's a little off balance. Oh, the source is right over there on the table. And it's 3.84 volts in. It's a boost buck converter. See now, what I'm testing is when I turn this off, 100%, it's off now. How long will that voltage continue to increase? I mean, it's steadily decreasing, but every once in a while it'll go up. But more so when it's slower. Oh. Let's check out the current while we're switching stuff around, and then we'll look at the oscilloscope as well. So about half an amp, 400 milliamps. That's not bad. The load on this is constant. I have the bridge rectifier connected directly in to the collector of the drive, so it's constantly got a load on it. All right, and oh, that looks naked, doesn't it? See, it was weird because I had it set up so it's probably these little coils right here. It's messing everything up. And that is 40 to 50 volt peaks. But again, that isn't what I'm testing. This is what I'm testing. See, it went from 12 to 13 to 12 to 13 to 12 to 13, but it'll continuously go down, but it's definitely getting a boost. And that's visual proof that you can feed it back into the system. It's not going to make it run forever, but it'll definitely help it run longer. And that's kind of what I'm after, like a practical, realistic, like just a booster to something, make it run longer. It's not going to run forever. Even, there's so many variables that don't last that long. So, I mean, it'd be cool though. Heck yeah, man, that thing makes some bomb ass music. Let's turn it on. I like the design on there, man. It looks like a fast spinning wheel or a record spinning really fast. There's 9 volts. Woo! Now I'm going to stand over here by the power because this thing's going to start to rock and roll. I'll give you guys the breakdown if you want in a second of what's going on here. Yeah, good luck. Good luck. I mean, I can spin this with my hand, but who wants to spin it with their hand, man? Who wants to do that? I mean, that's why got into DC brushless motors in the first place is because I didn't want to spin it with my hand. And even if I'm spinning it with my hand, it's an outside power source, so I don't know how that works. I can't wrap my head around it. Even if you're using Tesla coils or Rotor coils, you have a power input to make that all work. Now there is one thing that I saw, and it's an earth generator collector type mechanism. And I'd really like to see what that's all about. It ties into the frequency between the outer atmosphere and the center of the earth. And that's where we vibrate too. That's where we are as well. And to tap into that would be awesome. I don't know what it would convert into. I don't know if AC DC is really how it speaks. I don't know. I don't think so. Oh, that's all right, Nate. I don't hold it against you. Definitely not aliens. More of an artist. Sure. If you got a nickname for it, that's awesome. All right, let me break it down real quick. I don't know if I want to lift that off of there, but there's a maglev under there, so it's just floating there. This is the drive coil. It's got an 18 gauge wire, a 20 gauge wire, and a 32 gauge wire in it. It's a Trifilar coil. I'm using the 32 gauge as a trigger, and the 18 gauge is a drive coil, and then the 20 gauge coil is wrapped into the generator. So any transformer applications that are viable for the 20 gauge strand are now in the generator side of things. And with it, wrapping back into the collector of the drive, I don't see how we lose there. But I could put the 20 and the 18 in series and yada yada yada, but it runs so much worse like that. I mean, it's a little smoother, but there's way more power with just the 18 gauge. This coil is, let me think here, 8 26 gauge strands at 333 turns and two 32 gauge strands at the same rate. So this is like 3,000 turns, maybe a little less, of 26 and 32 gauge. 26 and 32, 26 and 32. These are both 333 turns. I think I'm going to take these out. They are kind of getting in the way, I think, of what needs to happen. This is 22,000 turns of 32 gauge single file, and this is 18,000 turns of 32 gauge single file with a soft iron core. So we get decent voltage, and we're going to get some amps because we got thickness in our build too. It's pretty good. And then just for the 20 gauge being inside the Trifilar coil, you get extra voltage just for turning it on. Basically equivalent to what you put in, on top of all of the generator stuff. So I mean, it's a win-win right there. And then from the bridge rectifier, we go over here to a 25 volt capacitor with 4700 UF to the drive, and that's it. That's pretty much it. All right, so I'm going to spin it with my hand just to get a reading. Oh, there we go. Yeah, and it does its little pulse there. That's awesome. It's for my enjoyment, your enjoyment. I don't have any like sponsors or purpose with it. I'm not trying to sell it to anybody. I'm not trying to I'm definitely not making things that I shouldn't be making. So I mean, if you're barking up the wrong trees, just stop barking. Orbs? You mean like ornaments? Orbs. I don't know. That sounds like Onimoshu. I don't think I'm gonna put the glass cube on there. We could definitely put this on there though. Look at that. Oh, that's awesome. They say put a load on it. I'm like, all right, I'll put a load on it. Check that out. All right, so we can change the load if we want, and we can light up a light bulb, but I think this is far more interesting what we're doing with the load being the actual motor itself. I don't have a Barney, dude, and I have 2 kids. I don't have a Barney. Oh, you want a light? All right, we'll see about getting the light going real quick. I don't think this is going to light up the way it is, though. Let me do something real quick, just to thin this out, and then I'll have my extra wire to continue lighting the light. There we go. All right, so we'll do the positive, just the live wire, or the small peg. All right, I'm going to disengage the one thing for the other for right now. Because the bridge rectifier can only has so many houses for the clips. So we're going to turn off our little booster, and we're going to turn on the light, hopefully. I don't know if we're doing enough voltage. Hold on. Oh, yeah. All right, so I think that's the on position. This is a 100-watt LED. So we're gonna see about lighting this up real quick. Look at that boost in voltage. That's what I'm talking about. All right, here we go. Let it get up to like 77, and then I'll flick on the switch. Yay, we got illumination. It's not that good though. So this is how much the 18 gauge performs. It's at 8.5 volts with 4 coils as a load. There are 4 coils right now loading this thing down. Because all of these coils are plugged into the light. Yes, sir. That's what it does. I mean, that might be what it is too, but that's not why I'm doing it. I'm just having fun. Hopefully this thing doesn't fly off the peg like the other one did. Oh, underneath? Dude, there's a void right here in the middle of the table. You can't see it. There's nothing to put it on. See that hole? There's nothing under there, dude. except a what do you call that thing? A shaft. Beef. Dude, are you having trouble building one of these things? Or what? Alright. So what I'm going to do now is I'm going to hook back up the booster engines. So we can definitely light a light. That's awesome. And now this should be different because I removed those 2 little coils. This should be way better. Thank you all for coming. I really do appreciate it. I'm having a good day today. This is freaking awesome. And it's already engaged. That's freaking cool, man. And just from the residual motion, we're getting that boost. 12. There it goes. If it goes up at all, you're getting a boost. Because I've watched it enough times slowing down that it doesn't boost itself. Just got to get it going with enough momentum to trigger the coil. Yes, there's definitely a flywheel effect, but the flywheel effect does not add voltage to the meter. You have to plug all that back into the drive for it to show up there. You know, you gotta. Because it's actual increase in speed due to the transfer of voltage back into the system. And there's definitely more amps here than anybody could, you know, could have guessed. I mean, the amps are pretty good. One whole amp. Check that out, man. That is good. I think I need a few more capacitors, or maybe one of these to do the e-bike thing. But yeah, that would be pretty sweet. I wish it was more stable, man. I'd let it build up, like go really fast. But this, you know, it doesn't need to go fast for it to do what it needs to do. I think we get a boost of ampage too. Yeah, that's pretty neat. I don't think in the upper, like the high voltage ratings, it's as prevalent as when it's low. Maybe. It might be able to charge a phone. I doubt it though. I don't know if it's that kind of I don't know if we're there yet with the kind of energy that was coming off this thing. Definitely need to put it through a few ringers, if you know what I mean. Oh yeah, and I was working with this lopsided pancake coil, my first one, and I got the spherical rotor to spin at 10 hertz with this bad boy. This is I believe a 14 gauge, or no, 12 gauge speaker wire pancake coil, and the ball resonates at 10 hertz. I'm gonna go grab that real quick. Hey Diddy, elaborate please. You seem to have a competent setup. I'm not negating your invitation for experimentation. This is what led to the brushless motors, and that people only understood one part of the system. Well, I guess. I always looked at the brushless motors, especially the way I built them, as more or less transformers. Because in input, I can run this thing on 2.5 and it'll get going. So input, gauge, drive is 666 turns of 18 gauge. And then the generator side of this thing is well over 60,000 turns of various gauges. Now when you put those together and you do the math, it works. It works really well. But you got to know the math. And if you, like he said, neglect the generator side of your motor. Anyway, there's my spherical rotor. And I just put it right here. And when I got it hooked up to a transistor, and bam, that thing will spin forever. As long as I got the power on. But I don't have it hooked up, as you can see. I'm just really excited about it being able to do that. You would think, you know, put it in the middle and it'll work the best, but that's not true at all. Heck yeah. That'd be awesome, man. Hold on just a second. And you know I got, never mind. I'm just gonna leave it there, diddler, because I'm not gonna put up with all the BS, man. It's all BS. mm. Look at that thing move though. It's like not moving like tremendously fast, but it's picking up speed as it slows down, which adds, at this speed, I want to say like 5 minutes to the rotation. Oh, this rotor is sweet. So a while back, I had a collaboration with a guy named Dolarath, and he made this gyroscopic rotor. It's freaking awesome. Like, I don't, I'm wondering. Because, I mean, with my finger, you spin it all the way around, it'll gyrate. So will the one in the middle. It's awesome. I like it. Thanks, B. This is pulse motor mayhem, bro. Now it'd be really mayhem if I just turned it up to 15 and let it go. That would be like devastation. That would break my wall. Listen to those harmonics, man. That is freaking pulsing. That's a nice chirp. Thanks, Couch. So with the 3 coils, it actually works a lot better than having those 2 other little ones in there. Thank you, sir. Thanks, Couch. I'll give it a rundown in just a second. See, the table's a little wobbly, though, so I can't let it go. I want to, though. All right, cutting the power. Oh, man. So in the beginning, it starts slowing down rather rapidly to get down to a more equilibrium speed. of what's coming in and what's going out. And just because of the laws, man, this is gonna constantly go dwindle. It's gonna constantly dwindle, even though it's doing what it's supposed to do. The lower the voltage gets on the meter here, you're gonna see it start to spike up. And that's what we're looking for. This is my 14-inch rotor. I made it about 6 months ago. It's got 12 very large Neos on it that are N52. This is the drive coil. It's a Trifilar. It's got 32 gauge and 18 gauge as the drive and the trigger. And then there's a 20 gauge strand which is hooked into the generator side of everything. So even the drive coil has got generator in it, which is cool. I like that. And then this coil has got 8 gauges, 8 strands of 26 gauge and 2 strands of 32 gauge at 333 turns apiece. This is 22,000 turns of 32 gauge. It's a very large coil. I mean, it itself weighs probably 2 pounds, maybe a little less. Yeah, a little less. About a pound, maybe a pound and a half. This is 18,000 turns, 32 gauge with the soft iron core. That's a 1/2 inch in diameter. So that's solid iron in the middle. I got to keep it farther back from this system, so we don't get the full benefit of that coil. But even having the partial benefit of that coil helps out a tremendous amount. And that's pretty much the rundown. All of these coils pour into this bridge rectifier. I don't know if you can see it. Right here, this bridge rectifier, and then from there it goes back into the system. It only works rather well when the power's off. See, there's the spike. It's more pronounced now. 11, 12, 11. But it constantly goes down. 12, you know. Let me show you. Power source is over there on that wood table. The round one. It's on the right. It's a buck boost converter. It's 60 volts, 8 amp, 480 watt power supply, DC. But it's off now. It's been off for 5-6 minutes. If you watched me turn it off. I'm sure in your mind you can go back to last week, but I'm sure that if you were going to time travel, it's nothing like what you think it's going to be like. And if you go backwards, you fucked everybody. That's why all the stories of time travelers are about them going into the future, because going into the past fucks shit up. It rewrites the present for everybody, not just you. Oh, I don't know about all the physics behind it, but I do know that That's the way I believe the past travel works, is that when you go there, you recreate the present. There's no present to come back to because you've now recreated it. Uh, that's just my opinion on it. I don't have any education, but it makes sense to me. Oh yeah, I think, like the movie Time Travel, Time Machine. I mean, you got that bubble encased in your, around your machine, so that that doesn't occur. Oh yeah, that sounds painful though. Yule, very painful. Sometimes hell comes to you, Joey. All right, this is Pulse Motor Mayhem. This is a rotor that is maglev. It has 12 neodymium magnets taped on here, so they're not going anywhere. They're glued and taped and cemented, and they're good. There's 12 magnets on here, and then we got the drive coil. We got one strand in the drive coil hooked to the generator, and these three are the generator coils. And then if we've got if we're looking at the meter right here, I'll give it a spin. Wow, just a spin and we're already at like 30 volts. That's great. Right, right. I just think what would happen to your environment if you went back in time. That means that not only like and not just like if you saw yourself, you do like a paradox and you implode and or whatever. That's not anything to really worry about. I don't think it's everything else. I mean, if you seriously like you interact with the environment at all, you've then changed your present. The present that you came from is no longer doesn't exist anymore. Yes, sir. It is a generator transformer pulse motor. Because speaking of paradoxes, I'll put it up to 2 volts, 2.5. 2.42. Move it in a little bit. Will that pick? I think it'll pick up on its own. This is 2.4 in. Let's look at the meter. How much are we getting out with 2.4 in? About 20. And this is hooked back up into the system, so it's under constant load. There's no need to worry about the load. Definitely a load on this. Every time that trigger hits, this thing is loaded down. Don't even need the light, which is cool. I mean, we could plug the light in. Yeah, that would be this right here, and I'm not using it. It's just being timed by the trigger coil inside the coil. This wire right here is what's timing it. So that's awesome. We're above a half an amp with the load and 28 volts. That's pretty good. 29. That's, I mean, at 2.5 in, I say anything over 10 is good. Especially for a radial pulse motor. If it was a serpentine coil or, you know, on a different style generator, I would expect more. But I'm you know, I think realistically. Yes, it does create electricity. Um, so that'll continue to increase in speed and voltage and ampage. And we're at 2.39 volts in. I think just the fact that it's going this fast is a thumbs up scenario, man. It's 2.5 is nothing. But since it's 18 gauge, I bet we're almost pulling an amp at 2.5. All right, I'm gonna turn it up a little bit. Ha ha ha. 12 volts. It's a nice quick pickup. So I just want to show you what this thing does when it's not under load. All right, so now the power is not being put back in and the light is not on. 5 volts in. Thanks, Jason. I'm pretty sure you do. Five volts in, no load. There's no load right now. Almost 200. Wow. 200 volts. Yeah, the flywheel does produce power. It does prolong the motion, but unless any of that stuff is hooked back into the system, it's not going to show up on the meter. It's going to continuously drop. It's just going to drop slower. Um, wow, and see, it gets really high when you don't have a load on it. But let's get the light on. That's just what I was getting at, that there was definitely a load on this thing the whole time. So, I mean, I get negative press because people say I need to put a load on it or it doesn't matter. And I'm like, dude, there's a load on it. Straight up, man, that's great. So that's residual. And that's a 100-watt LED. So it takes a little bit of juice to get it lit, but it'll light up. What do you want to see? The lack of load on here. I'll just do it from the switch. Move that soft iron out a little bit. There it goes. Yeah, the attraction between the soft iron and the magnets on this thing is super, man. It is like almost magnet to magnet super. I think it needs to get up to about 77. There it goes. Boom. Light is being lit. I know it's lackluster, but I mean this light takes a lot to get going. It takes a lot. It's bigger than any 90 volt or 120 volt light you can do. So, boom, turn that off. You can hear it kind of picking up. Maybe you can't, I don't know, but it's definitely picking up speed. That's bright now. That's good. Nice. Now, I'm going to turn it off, and I'm not going to plug the booster in. Let's see how it diffuses now on the meter. So this is flywheel, typical flywheel. It's definitely going down a lot slower than it normally would. Heck yeah, it's a little off balance, Arctic, just a little bit. You'll see when it gets going, the whole table will be going like woo 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 woo. It's bad. See, constantly going down, and I'm pretty sure once we get to like flywheel, um, where it's substantial, it's going to continuously go down. It won't have any boost to it at all. Yeah, I'll try all the 0 point crap when I learn more about it. Don't know anything about that. I do know that there's a part like right next to the magnet where there's like no magnetic field. Um, this is a DC brushless DC motor. The current that I'm using on when it's coming out is DC as well. Got a bridge rectifier. Right over there. Boom. So DC, DC. Oh, that is, wow, we got it. I was wrong. Ah, but I think it's still dropping at a more significant rate. But yeah, wow, the flywheel is giving it a boost. I just never noticed it. But I think it's way less significant than if it was plugged in. Way less. See, this is going to stop in like 30 seconds. Merry Christmas! Merry Christmas. Happy holidays. Here, let me zoom out. I apologize for that. Here we go. Oh, let me get that up here real quick. We'll get a look at it. All right, let's turn it on. Turn off the light. I do like the flywheel aspect of this machine though, because I always like the extra spinach that you get. And if you get your electricity, some of it from the spin, then that's obviously a good thing. It's definitely sine wave. There we go. All right, so there's our basic wave. We're only pulling about 50-volt spikes peak to peak right now, though. And that's because the system's sucking the voltage out. But if I take this off, look at that. Wow, that's freaky deaky. Well, all the cores that I'm going to make are going to be 3D printed iron or copper infused PLA. That's what I'm going to make my cores from. Because they got it up to 60% and 55%. So, I mean, that's pretty good. It's solid. And if we're doing it just for like the permeability, definitely iron copper infused PLA is good enough. It's actually quite a good magnetic flux. It's not too strong and it's not weak. So this right here is an iron infused PLA core, and I got 26 gauge wrapped around it, like directly on it, and that's probably not good. It was experimental. It didn't work out, but this is definitely 100% iron infused PLA core that will fit in this bobbin. Wow. That is awesome. So this is just spinning unabated with no load, and that's awesome. That's pure flywheel right there. And I figure since all these bobbins holes are all different sizes, printing the cores is going to be my best option. See, it's the core, it's the pegboard that I'm worried about. Really, like the pegboard. Look at that. Look at those readings, man. That is freaking awesome. It's like sawtooth. Let me make sure this is right. Yeah, that's good. Because I got the, see now it's plugged in, sucked all the power out of there. You see that? That's a big load. Breaking Bad. Merry Christmas. Mm. So I'm gonna lift the rotor up. That's one thing I haven't done. Show you guys what's underneath this thing, and it's pretty cool. I mean, it's nothing, quote unquote, breaking the rules. I guess it's nothing like that. So you got these two N42 Neo that go right around the shaft, and it's Maglev like right around the shaft. And that's it. That's all that's under here. And this shaft is fixed, like it does not move. Oh, look at that skill. Woo! That's good to say myself. Woo! Yeah. I got a different design for that. So the sculpture is going to now have 10 millimeter shafts, and this is going to be the design for the rotors, kind of UFO like. Now these bearings don't spin as well as the little ones do. I might have to reprint this too because it's very uneven on the bottom, but it spins well still. No, I'm not trying to create a black hole. I don't need a mechanism to create a black hole. That's my appetite. Oh man. Nope, I'm not in the habit of making black holes. If I was going to make a black hole, you would know about it by now. I don't mean to be rude, but that sounds like something that I could go to jail for attempting to do. So I'm just not interested in alternative thought processes right now. That's not true. I like alternative stuff, man. I really do. But like dangerous things, bombs, black holes, time travel, I don't mess with it. Just a pulse motor. And I know that you don't like mean anything by what you're saying, but you know, I deal with lots of different people all the time. We're going to spin it the other way. Look at that reading, dude. That is cool. And this is made. I'm not trying, there's no trying to do anything. This is a finished product, basically. It's very interchangeable, though. For instance, this coil right here, well, it's kind of caught up in the wires right now, is a Litz coil made with 20 gauge wire. So it's 12 strands twisted, and it's about, I don't know, 50 turns. It's awesome, man. It has an acceleration phase that is unbelievable, and it pounds so hard, it just never stops increasing in speed, at least in the actual flux. I haven't reached its potential, and it totally destroyed my rotor. This coil was continuously increasing in speed, and then my rotor broke. Literally, it threw a magnet this way, threw a magnet that way, and the rotor went that way. Boom! That was physics 101 right there, and it was violent. Let me show you. Yeah, man, it was violent. And I don't personally like events like that, but I got it on my live stream, my birthday live stream. That's when it happened. And wow, man, when I saw the shaft, I was like, oh my God, I'm glad nobody was in the room. I'll give you a cookie if you can tell me who that's supposed to be. And you can see how like bogged down it is because of how I have it hooked up right now. This is 6.9 volts in, and that is extremely slow for 6.9 volts. Alright, so it definitely puts a load on it, without doubt. But I think it even spins better without any load on it. As a flywheel only, and it spins great. Heck yeah, man. And I think because of the fact that there's no load on it, allows the speed to increase. But again, you know, you get to this point where it's always going to steadily decrease. But definitely the flywheel activity of the whole thing is really showing its true colors right now. And that Maglev under there is awesome, man. It's powerful. And there's 2 ceramic bearings in this rotor. Mm. Now we're going to do the same 6.9 in, 6.5. Watch how quickly this picks up. Compare it in comparison. It'll go way faster. Interesting to me. But this is also proof, a lot of people say that you can't like put the energy back into the same system. But you can, but it doesn't work the way it's supposed to. It actually slows the system down as a load. However, the energy produced is more pronounced. I don't think you get any benefit from it though. Woo wee! 6.5 volts. It's getting a little unstable there. I think the 18 gauge coil for the drive is really awesome for this. And just the 18, I could do 18, 20 in series, but just the 18, awesome, because that will double the length if I put the 20 in series with the 18, and you'll have to put more in to get the same amount out. However, you'll have a steady, more potential acceleration phase. So it'll accelerate beyond what it would with the 18 gauge alone, but it's going to take twice as long to get there, and you might have to put in more voltage. Heck yeah, the circus freak. That definitely, man. A carny, dude. This would sell at a carnival, man. I don't do carny things. I go to the carnival. I've known quite a few carnies, but maybe. Because we had this place called the Trade Center North. It was basically a flea market, a huge market, man, indoor market, trade center. We had a booth in there, and the carnival would come by once or twice a year. And that's how I got to know everybody. I worked at this place, and I sold tarot, astrology readings, and crystals, quartz, all different kinds of precious gemstones. That's what I did when I was 18. It was awesome. I loved it. Didn't make much money though. I mean, for what it was, I guess we made some money, but yeah, I don't know. It was fun. Now what I think I can do is connect these coils with a DC rectifier in between them. So put one of these in between each one of the generator coils going in a certain direction and then spin it in that direction. We'll see how much longer it'll go for. You know, things like that. So you don't have to do too much to get that what you're looking for. And you're not even looking for very much or very pronounced amount of change. You're just looking for any change. But in this instance, this coil will pulse to that coil, will pulse to that coil, will pulse to the drive, and it won't backtrack. There will be no oscillation. But that will also kind of in turn all of these into drive coils. And it's not like it's going to be like turning the motor on. It'll be like you turn it and it'll continue to spin, you know, just more than it would if you didn't do it. And that's kind of what the tests all today have been about. And I'm thinking that the flywheel itself is coming out on top of things for generation purposes. But here, let's do this. Yeah, this clip's not that great. There we go, I think. Wire's not that great either. Okay. So now these are connected via diode. And now we'll get the other one connected too. Oh, we want to do this. We want to take it from here. I'll put this now. So this is each coil connected. Oh, that didn't work. I think I need, hopefully I got it in my pocket. Yay, all right. Okay, so now they're facing this way. Let's turn it this way. It's hard to tell whether it's helping at all. I think we need to put a load on it just to level it out and get rid of any excess energy that we're not, that's skewing the results, I guess. So, but all these are hooked to the bridge rectifier. I was wondering, like, um, no, this is good. I don't know if it's doing what it's supposed to do, but it looks like it is. All right, well, looks like blah. Take that off. It went right up, but that's okay. I was thinking if we got rid of the oscillation, that there might be less drag. Um, these? Yeah, these are coils. Let me explain. So you got 18, 20 gauge, and 32 gauge in this Trifilar coil right here. All the drive is in this coil. 18 gauge drive. That's all that's pushing this thing is an 18 gauge strand. 32 gauge trigger, and then the 20 gauge strand is hooked into this coil, which is 26 gauge and 32 gauge. About 3,000 turns altogether. This is 22,000 turns of 32, and this is 18,000 turns of 32 with a soft iron core. The rotor itself has 12 neodymium magnets on it that are 40 millimeters by 20 millimeters round. So it's like one of the most powerful magnets I could get online for the rotor here. Nah, man, this thing is heavy, dude. I need a drill that is not run on a battery. I've got the power drill thing. It doesn't need to. No. Power drill, bad idea. You don't need that. Besides, it would break my drill. Okay, let me turn it back on. Thank you. All right, all right. Oh, cool. We still got half power left, too. So with the DC rectifiers in between the coils, we get a lot less voltage um, going to the bridge rectifier. So in my opinion, those diodes that we put in there just now are totally counter working. They're not working to our advantage, they're working to our disadvantage. At least for the output on the meter here. As for directional stability, it might be working. I couldn't tell. I'll have to spin it the other way once it slows down a bit. Thank you, Lizzie. I love the design on this rotor. It's oil paint, actually. So, like, people look at the stuff and they're like, God, you need to brush up on your engineering skills, dude. And I'm like, dude, I'm not an engineer. What's up, somebody? I don't know. I would definitely say it falls within the realm of physics. It's more or less a transformer, so you do get more out than you put in based on where you plug your meter in. But if you do the wire calculations, you got 18 gauge at whatever voltage you put in. If you do your multiplication and your step up math, you're going to find out that the stuff coming out is equal to what's going in. Because 18 gauge at 2.5 volts, you're probably going to get, you could get up to 118 volts coming out. And that's normal, because this is a transformer, a step up transformer. Oh, that's cool. Propulsion technician. Wow. That's what I said, man. The first actual trip to Mars, I'll be on that trip. I'm not joking, man. If they let me go, I'm going. And who the hell would want to go to Mars on the first trip? Me. It's like not like I have a death wish or anything like that. I just, God, that would be awesome. And I got a whole like idea scenario for like recreating an atmosphere on Mars. Hell yeah. All you got to do to recreate that atmosphere is bring things that grow in your atmosphere and have them in a confined space with one-way air travel. So all of the, and a lot of that would be, not all of it, because of the atmosphere of Mars is thin. So a lot of that gas is going to escape, but a lot of it's going to be caught. So I'm talking like a tree grove. You encase it in an area that is more like your atmosphere, and then that air that leaks out, it's gonna. Thank you, Temer, I guess. The Earth is flat. Thank you for your glorious insight. Let me guess, there's a big toroid in the middle. I'm doing a pulse motor. We're trying to see like what methods we can use to prolong spin. It's a flywheel, so that's one method to prolong spin. This thing weighs not that much, but the magnets on the outside are where all the weight is. So this is almost hollow, and the weight is on the outside. So that actually increases the centrifugal force of this whole thing, which and the inertia. Inertia mainly, but having the weight on the outside definitely helps with that. You can make the whole thing solid if you want, but I didn't do that. This is old. I would have done 100% had I done it today. I would make this 100%. Then it would be a true flywheel. Thanks, Lizzie. Bye now. So it definitely seems like this way spinning it is a little more choppy, a little more slow. A little bit. And go the other way. I think those diodes are actually doing something. I might be totally crazy, but I think they're actually doing something. But as for having anything else going on right now, I don't. Let's just this is a soft iron or iron infused PLA. That's a strong magnetic connection right there. So that's cool. I like it. And I mean, like, if terraforming Mars's atmosphere is something we want to do, then the more groves we make, the quicker that'll happen. This is a transformer, so it's actually putting out. I'd say. Oh, let me do the math real quick. We'll say this is 600 turns of a drive at 2.5 volts in. And then we're going up against maybe 60,000 turns of a generator. So if we do that ratio, we get about 130 volts out at 2.5 in, but the turn ratio makes that legit. So let me turn it on. So this is an 18 gauge drive at 666 turns. And currently we're at 7 volts in. Now the reason it's so low is because we have rectifier diodes between each of the generator coils. So we don't have any oscillation feeding the bridge rectifier anymore. So It's all kind of a straight DC. But even with the diodes in there, we're at about 6 times more out than we're putting in. Yes, you could run it off of solar panels. You can run it off of a cat bank. You can run it off of a battery. You can run it off a Tesla coil, I'm pretty sure. See what we're looking at. All right, it's 10 times now. That's awesome. Even with all the rectifiers in there, we're still at 10 times. Thank you, Red. Thank you, William. Since it requires such little amount of voltage to actually turn itself on, I'm pretty sure that anything could run this, as long as there's some current involved. .7. You could hear it kick on, maybe. Thank you, sir. This is a pulse motor. It's a pulse motor generator transformer. This is a 14-inch rotor with 12 neodymium magnets on it. I say for 12 magnets, this is whipping right along at 2.7. It's got 2 ceramic bearings in the middle. It's Maglev. It's running on a 666 turns of 18 gauge and 32 gauge as a trigger. Then all these coils and the center coil of this Trifilar coil over here are all hooked up in the generator. And that is hooked up to the bridge rectifier, and that's what we get right here. But here, we're going to do this in live time here. 0. Look at that. Alright, so we're taking that rectifier out. All right, what do we got now after taking those out? Yep, look at that boost. Oh yeah, oh yeah. .7. 2.7 volts. I wasn't kidding, man. That's almost 118, like I said, but it's going to stop a little short, I think. Let's check out. Oh, turn it off and then turn it back on. The amps, 700, 800 milliamps. That's awesome. I mean, any amps that you're going to get off of 32 is awesome. That is just whipping right along, man. 2.7 volts in. Crazy good. And see, it doesn't have to go super fast to get good results. It doesn't. You can put very little in. This is great speed at 2.7. Wow, that's a lot of amps. Holy cow. Well, it doesn't actually run by itself. Even when you feed all the generator back into the drive, it's not going to run like that. It'll be boosted, basically. Especially if you have a capacitor. Every time the capacitor dumps, you'll get a boost of speed, more voltage on the meter. You'll notice it. It'll show up on there as like going from 10 to 12 when the power's off. And then the flywheel application is the same. This coil is kind of wobbling around. Wow, man, it gets more rolling around than it does me holding it still. So we'll cut the power. This is a pulse motor. This is a 14-inch rotor with 12 neodymium magnets along the outside. We got a 18 gauge drive. We got it's 666 turns of a drive, and then we got about 66,000 turns in the generator. So you get about 10x. You put in 10, you'll get 100. You put in 2, well, actually we almost got 120 just putting in 2.7. Now granted, there's no load on this right now. So that's like max voltage, max ampage. You put a load on this, that's going to cut it in half at least. But it's still going to be 10x. Or maybe a little less, like 6x. Because it's a transformer. That's what it does. It's a step-up transformer in and of itself. And it goes from a 666 turn drive to a 66,000 turn generator. 10x, or that's not 10x, that's a 100x. But that's not right. It's like 50x on here without a load. Well, I'll put a load on there and we'll turn it back on. Currently, I'm going to hook the generator back into the drive as a load. It's a more constant load than a light. Not really. It's about the same consistency. It's definitely a higher. So now all that generator energy is being put back into the transistor that's running that pulse motor through a cap and a diode. All right, here we go. You can see that the 3.95 that I'm putting in now with the load on is extremely see, now this will not get going as fast as it did before, ever. I have to put up like 20 volts to get it going. Let me see here. Oh, thank you, Creative Ideas. This is used for generating electricity and experimenting with ideas in perpetual motion. I don't believe in perpetual motion. I believe strongly in physics, and that all of this, even though it's like 50x, 20x, can be explained by physics or by math. If not physics, it's definitely mathematically sound. What I mean by that is like the amount that I'm putting in with a load is 3.95 volts. What I'm getting out with a load is 10x. You can hear that thing chirp. But you see, that's it. That's its max speed with this load on it. But if we do this, let it speed up a little bit and then clip it on, then we get way more generation happening. Let's try it like that. So the load is off right now. We're at 3.95 in, and we're basically getting, what is that, 20x now? I mean, let's look at the current, just so nobody's like thinking, oh, well, he doesn't have any current. 1.7 amps, guys, that's a lot. There we go. That's a beautiful wave right there, a little McDonald wave. That's 150 volt peaks. That's awesome. See, I hooked the load back up and boom, everything disappeared. And there it's back. Alright, sweet. So maybe we can't necessarily consider that a load. Maybe it's just something that shouldn't be happening. Yeah, I got some SLA batteries. It's not what you think it is, though. When you're putting it in the battery pushes it back out. Or most of it, anyway. So I never really had much love for batteries. And now I can't even charge it with a car charger because I spiked it. Once you spike a battery, you can't charge it any other way. But yeah, I got all kinds of batteries. I got this 12-volt pack right here. I don't know where there they are. They're over there, but I have two 12-volt SLA batteries that I now can't really charge. I can charge them with my SG circuit, and that's it. That sounds cool. Heck yeah, man. The hydroelectric turbine, especially Tesla's version of the hydroelectric turbine of viscous fluid, not water, but like oil. That thing is awesome. And you know what? He didn't like totally get that one streamlined because it would keep melting at around 20,000 RPMs. Oh, I think it would make a lot of power. I think that would make a lot of power. Wow, I think they reset the time on my live like 4 times already. Maybe not. I don't know. Well, that's definitely new time there. Says I've been on for 1 minute and 47 seconds. That's so cool. All right, so let's get the oscilloscope reading. I'll move the coil in. We'll get some good readings here. .3. Look at those spikes on the top of the... Wow, dude. I believe that's from the 20 gauge strand inside the drive coil. That's all vibrant like that. That is so cool. And you can tell now that I've turned it off, that vibrant spike is gone. Because that only happens when the power's on. Wow, that's enthralling, dude. That is so cool. That's 268 volt spikes. So I believe the spikeage that we're getting on the oscilloscope is a lot different than the actual voltage. It's got BEMF in there too. Look at those spikes, man. That is intense. And that has amazing flywheel capabilities. That'll spin. It's going to spin for a while. But definitely, if I'm going to do a battery, I would have to have a cap dump that would hook to the bridge rectifier and then dump into the battery. Because I believe it going, a tenth of a volt at a time, it has too much of an opportunity to force the voltage back out. But if you do it like in bursts with the cap dump, I bet that all this energy could be saved and used at a different time. Yeah, I could probably do that. That might actually be, besides using the buck boost converter over here, I do have one other power supply. Actually, I have a lot of power supplies. Man, this thing is heavy. Ooh, this thing weighs a ton. Oops. So yeah, I can do that. That'll be sweet. Actually giving that a boost, giving that a shot. I don't know about jacking this thing up to full power though, man. It needs a balance adjustment before that even comes, reality. This thing weighs so much. Holy cow. Holy cow. So I actually have to get used to using AC before I actually get using it. So I would imagine that me hooking the AC up to the DC, or I mean up to the transistor, I would hook it up the same way that I hook the DC up. That's what I would assume. Yes, this is a pulse motor, generator, and transformer. The big flywheel here is 14 inches. Has 2 ceramic bearings. It's Maglev. It has 12 neodymium magnets that are freaking huge. They're very powerful. It's got great flywheel capabilities. It's got 600 turns in the drive and 66,000 turns in the generator. So it's easily 10x to 50x on the output. What am I doing? I'm going to spin this. Look at that. Look at that wave you get just from spinning it, dude. And that's on its basic setting, so that's got to be at least 100-volt spikes. Listen to that chirp. Aha. That's 12 volts in. Look at that rambunctious freaking thing, dude. Oh my God. Over 200-volt spikes there. Oh, I'm not even going to get close to that. You see how the table's shaking right now? This is only 12 volts in. Haha. I'd say the max RPM for this is probably going to end up being around 3,000 if I ever get it balanced out right. Because then I can just let it build up and continuously build up until it reaches potential. I never let these reach potential because they're just a little lopsided. But I taped them in there so the magnets won't fly out. Hey Kangaroo, man, it's a pulse motor. It's a transformer. It's a generator of electricity. Jesus is in heaven now, Stephen. Jesus is not with us. He's in heaven. Yes, sir. Very much so. Yeah. There's no, I can spin it with my hand or I can spin it with the motor. You got to juice it up for it to work at all, you know. You got to put some in to get some out. And you're going to get a lot more out than you put in. This one, that is a Tesla pancake bifilar coil. Works pretty well. Oh, these magnets, as long as you touch them to another magnet of its kind, you can bounce magnetism off of magnets for as long as you want. You just have to remagnetize it after a while. These are going to last probably 500 more years. Yeah, I can spin my spherical rotor on this coil constantly at 10 hertz on my on this pulse width generator. Just put 10 hertz in there and it'll spin forever as long as the power's on. Yeah, it's not perpetual motion, man. No, sir, Bryce. I don't really believe in that. I believe in prolonging defeat, I guess. I mean, if you it's like a safety mechanism when your electric car runs out of battery. So, or the battery gets really low. Then you put 2.7 volts in, and you get enough to get to a place to plug your car in. I don't know about braking. There's definitely no braking going on here. We're actually trying to remove all the brakes and see how long it can spin for without power. And it's not the objective, it's just something I'm looking at right now. So it's 3.27 in right now. I'm going to turn it off. Now the power is off. Maybe 2 more minutes of spin time. We're not looking for anything like blow your mind kind of thing, but we're just looking at minute changes in the amount of spin time and the amount of generation after turning the power off. So now that it's going, I'm going to plug this in. And you can see the wave change as I hook the load up. Almost to nothing. Well, part of it is kinetic energy, yes. So the motor turns it into kinetic energy, which spins it, and then the generator picks up the induction from the magnet passing the copper. So it's doing both. It's definitely doing both. And then that energy is, right now it's being fed from this bridge rectifier back into the transistor, which fires the drive. And that's just, it's a huge load on everything. So this is with the load hooked up, which is the system itself. So this is with the power being fed back into the system. Thanks, Rook. All right. Thank you. I think it's fun, and you see things. You're definitely going to see a lot of what people say to be true. Okay, you put something in, and mathematically you're going to get this out. It's not necessarily going to be the same in as the same out. If you have a 10x, there's going to be a reason why you have 10x that falls within the laws of physics. And you have to disclose that. You have to say, yeah, the reason that you're getting more out is because it's 100x turns on the generator side. So there's 666 turns of a drive, 18 gauge, 666 turns. Then everything else on here is in the generator, and that's about 66,000 turns. So that right there is wow, it's a lot of X's right there. Again, thank you all for showing up and digging this with me. I really like sharing this stuff. It means a lot to me that I don't have to do it by myself. Although I can. I totally dig it. Alone or with someone else. It's all good. This is just one iteration of one thing that I've done in the past 3 years. Hey, Jessica. Altogether, I would say I've spent over $5,000 doing this. But I have a whole storage unit full of stuff. See, this right here, right now, is got more torque than I could get off of my drill. I'd say the goal, I can't really determine. Yeah, definitely just do something with the energy, quote unquote, something with the energy that is being generated. Either to cycle it back in, or to run another motor with it, or to save it in a battery. Virtually, there's an output, and you can hook it to anything you want. I would not shortchange myself, although a lot of people would not consider it to be shortchanged to have a goal. But in this instance, it would definitely hinder my progress. I know how paradoxical and oxymoron that sounds. And I'm sure he does, looking down at me from heaven. And besides, if you were to come back down right now, I'm pretty sure a second coming wouldn't be a good thing. Sean, yes. Sisson, I had a teacher named Mrs. Sisson. Awesome. All right, so Sean, let me just break it down. If you don't find the answer that you're looking for, maybe you need to ask a different question, but I'm going to break it down for you. This is a 14-inch rotor. Okay, this is a pulse motor, generator, transformer. It does all three of those. Has 12 neodymium magnets on the peripheral here. You got 666 turns of a drive, 18 gauge, 32 gauge trigger. So this is a Bedini style Trifilar coil. So that this will fire itself. And this is the drive with 666 turns in it. Then we got 666 turns of 20, 3,000 turns of 26 and 32, 22,000 turns of 32, and 18,000 turns of 32 in the generator side of this thing. So 666 turns to roughly 5,000 turns, 50,000 turns, my bad. So you can see that that scales up. A step up transformer 50x, right? You do see how the ratio of 666 to 66,600 is square to like either 100x or 50x. It all depends on how much voltage you're putting in. Say 2.5 volts. Yeah, and I know how elaborate those coil mechanisms in those things are. They're huge, and they basically follow the same principles. See, if you're working with water in a hydroelectric dam, you got to work with the weight and the pressure, the PSI, all that stuff. And mathematically, you're going to already know what you're going to get out of it, or should get out of it, before you even turn it on. That's cool, man. It's basically one of these with an impeller below to catch the torque. I see. No, I don't think it's different, really. Instead, there's no difference instead of the fact that I'm using electromagnetism to spin it instead of water. But yeah, it's virtually the same thing. And I'm just saying it's on a much more grand scale. And I would love to see the power generated from that. Just one. It's called a jackal. Hell yeah, man. Yeah, you see, the transformer setups. They're about that size, shed size, just lined up along the road out here. Sure, Norfolk boy. This is a pulse motor. It's a generator and it's a transformer. This one just happens to be 50 to 100x without a load. This is with a load. It's basically 3 volts in, 2.93, and it's 10x out. A little bit more than 10x out. It's legit. 100% legit. This is a transformer. Yeah, I understand those cycles that start all over again, but you've got to factor in the loss. Even in space, you're going to have loss per cycle. It happens. So every single time you cycle through, you're going to get less and less out of it. You know, the only person, I don't know what to say to that, Norfolk. Oh, man. No. Nope. Definitely not doing something for nothing here. Look, man. Dude, I already don't like how rude you are. Oh, you're a fucking idiot. That's why. Oh my god, dude. Oh man, we gotta get the rotisserie chicken filleter out here right now. The equation is a step-up transformer equation. You you have 666 turns of a drive. You have 66,600 turns of a generator. Oh my god, dude. You're such a little punk. I don't even know why people gotta act like that. Tell me how to do my show? That's okay. No, he was just being really rude. Oh man, you can't come in like 3 hours deep when I'm like, my head's starting to spin and be a dick like that, man. Bye. See you later. Thanks, man. I appreciate you, Brad. I love this shit too. I try to keep it as lack of controversy as I possibly can. Everything that's on the table right here, on the input over here is 3 volts, and the stuff on the meter, it's all legit, man, and it all can be explained with math. It all can be explained with a frickin' ratio. Absolutely, man. The ratio is not the golden ratio or whatever, but like 6 to 60. That's the ratio. That's funny, kangaroo shorts. That's awesome. You find my lack of controversy controversial. No, honestly, man. People that claim like free, I don't know, man. I don't believe in that. I've tried everything. I've tried combining systems. I've tried all different kinds of things because I used to think that it was possibly real. And all that I believe in now is that you can prolong the life after you turn it off, but you can't make it go forever after you turn it off. You can't. Even in Star Trek or Star Wars or all of it, man, there's always a source. There's always a source. Even if that source is unexpendable, it's not free. Okay, you have a source. If you don't have a source, then you don't have a circuit. Yeah, it's a pulse motor. Legitly, it's a transformer. It's running at 3 volts right now. It's heavily loaded on itself, so all this generated electricity is going back into the drive as it's on with 3 volts in. This is what we're getting out with the load on it. 10x is what we're getting out. So I'm going to turn it up to 4.4 and I'm going to disconnect the load. We're going to get a free spin here, basically. So 4.4 in, and we're already to, I'd say, 12x. But this is unloaded, so there's no load on it. We're just going to see how fast we can get it going and how much we can actually generate. I don't like how this coil's rolling. I'm going to put it in that little groove and see if we can't solidify it like that. Wow, that's getting a lot of speed for 4 volts. Woo! Alright, so basically about 110 volts at 4.4. They can go more, but now we'll turn it off and we'll get flywheel action. The bearing, these are ceramic bearings that are 1/2 inch with a 1/4 inch inner diameter, and it's Maglev on 2 neodymium washers, basically. They fit right around the shaft. Thank you, sir. G-Man, you the man. Gerald, right? Or is it, I got you on my, my subscription list, but I don't, Gerald. Is your last name Wayne? Gerald? Okay, good, man, because there's this guy who I thought he knew you, and he thought that maybe you were me, and he got confused, and he was, I don't even know. But he called me Gerald Wayne, and I was like, dude, that's not who I am. Oh yeah, more than likely. Like I'm so rich that, you know, people gotta steal from me. Yeah, right. So let's put in 2.56. Which way we want to spin it? Eeny, meeny, miny, mo, catch a tiger by its tail, wait for how to let go, eeny, meeny, miny, mo. So it's currently unloaded. .5 going in. And I mean, just because the copper is so like stacked on the generator side, it's already 20x on the output for voltage. Too bad I don't have an amp draw reading for my power supply, but we got 1 amp too being generated. Unloaded, of course. We do not have a load on it. Currently, I'm going to put this load on here, but it is 2.5 in. I don't know if it'll continue to run. Yay. All right. But you could see that it went down pretty drastically. Wow, it's definitely slowing down. That's a huge load that I just put on there. And it's like the whole thing is now loaded on itself and everything's slowing it down. So I'm going to put a little bit more power in. 6.5. And that we're at 5x. Pretty much 5x. Now the whole idea about this load is when I turn the power off, we're going to let it speed up a little bit. Well, when I was designing the rotor on Tinkercad, I would, I believe it's 30 degrees of separation, if I'm not mistaken. Every 30 degrees I'd put a hole. Brazil, what's up, my man? And then I glued them in, and then I taped them down. So they're in there pretty good. They're off balance slightly. So if this thing gets going any kind of RPMs, really, I'll demonstrate. The table will start to shake back and forth and violently at times. Absolutely. .1. Woo! That's a lot of amps. For a 32 gauge wire, that is a lot of amps, dude. But we got 20 gauge that's acting as a transformer, so most of our amps are probably coming from this 20 gauge strand. Heck yeah. And it's loaded too. 12.2. And it's loaded. So this has got a load on it. That's awesome. But you see, we're only generating 51. volts at 12.2, that's 5x. Well, a little less. And then I'll cut the power, and we're going to see if the generator will filter through the bridge rectifier and be enough to prolong motion. See, it still goes down, and it'll go as long as it's like above 20 volts being generated, it will still consistently go down. But once it settles, you'll see it start to go up and down and up and down and up and down, and it'll stick around, 10 volts, 12 volts for 5-10 minutes. So the current is definitely in series. Well, actually, I'm just coming off the bridge rectifier. All this is data off the bridge rectifier. So there's only two places to hook it up at. Well, you can do an AC version and a DC version off the bridge rectifier. What's it? What's it? It's connected correctly, whatever you're trying to get at. Via diagonal, it's right. Yeah, there was this one twitchy guy, and he started, throwing mud at me and saying, "Dude, you're full of bullshit because you're not doing your meter right. You're not one of those guys, are you?" Okay, no, I understand. I'm asking because that guy was a real doozy. He got like upset with me because I wasn't doing it the way, he wanted me to do it, and I wasn't happy about that. But see, look at that. That's definitely fluxing upwards. But as it's consistently going down, it's being boosted up, especially when it gets down to this speed. Yes. Oh yeah, you're absolutely right about that, man. See, watch this. All right, the AC and the DC off a bridge rectifier, even not off a bridge rectifier, they're definitely going to have different, like amp reading for AC and DC are way different. See, like that. But I'm definitely not measuring AC. I'm not even really using AC at the current time. I do. I have a variac transformer. Regulator goes from 0 to 130 AC volts. At it looks like 1 volt intervals. Ah, yeah. No, I got one. This one does that too. All right. Now, let's get some. Oh, we're going to take off this load. This load just seems more and more dumb as time goes on because it totally sucks all the power out, but it puts it right back in the system. but I think ultimately it slows the system down. See, you take it off and it just spins freely. It's awesome. All right, let me get it going. We'll get some. See, now you'll see the transformer part. Take action here. See how that wave changed? Oh no, not yet. Oh my God, what's going on? Oh yeah, it's there. We just need to make it bigger. See that wicked like spike in one of those bumps? That's from the transformer. Yeah, that's EMF for sure. But you now watch, when I turn off the power, you'll see that vibrant spike go away. No, I do not, sir. Or maybe I do and I just don't know it. I don't know, but I've never heard of it before. But as you can see, that vibrant spike is gone now. Because I work with DC, not AC. I haven't done any AC work since I started, and I'm just getting into it now. The only AC energy that I use is the ones generated from the coils. And then I just bridge rectify it. Turn it into DC because all this stuff runs on DC. I haven't run it on AC yet. I don't know what that requires. To convert it to DC, I'm not using AC. The buck converter over there is DC. All this is DC. Man, but those Tesla coils look awesome, dude. I gotta show you something, and we'll see if we can't get going on that. See, like this for an exciter or a slayer or something like that. Oh, I am. I am. Gaming nerd, dude, I am listening to you. I've never heard of it before. But as for the question about why use a bridge rectifier, and you already answered it. I know. That was William. Oh, it is. Dude, this is heavy duty full wave. This is for like a washing machine or something. Carl, what's up, man? Okay. Well, I mean, if we're gonna totally like write stuff down, I would definitely glue all this stuff to the table so that it doesn't move around, because all this stuff has been moving around the whole time. So, I mean, I like personally it being able to move because then I can put it where I want it, whenever I want to. But yeah, if we were going to measure the coils, I would make sure that they don't move around, that the air gap is the same for all of them. I might actually run one at a time, just to get the different power specs for each coil. But I know enough to know that this 20 gauge strand right here gives all the awesome readings on the oscilloscope, because it's transformer. You get power off of the transformer that you do not get from the induction. It's different. You get way more amps. You get just an instantaneous burst of electricity going through the transformer strand. And if you did it right, you'll get a 1-to-1 ratio from your transformer strand. Oh, William, I appreciate you too, man. I just, yeah, I think you answered your own question on my behalf for why I just call it a bridge rectifier, man. It's the real deal. It's the 4 diodes. That's what this thing does over here. And thank you. I appreciate everybody's input. And yeah, if it wasn't for you guys, I'd be not knowing how to do this at all. So, oh, keep going, man. It's all good. Okay, I'll shoot you a direct message sometime. Yeah, I'm interested in getting into using AC electricity more, and maybe using both more, and then maybe using Earth's resonance more. I mean, literally, I've seen this Earth collector mechanism that just literally, it's there to take. So if you can find a way to collect it, it's there, you know. Very cool. I don't know I think it may even be an AI development. I don't remember who made it, but it's very cool. Maybe even 3D printed. Um, and oh, here, I got 2 of the pancake coils now. All right, so I got 2 pancake coils. One's a 12 gauge, one's a 14 gauge. Well, you want to do gauge, wire gauge, number of wires, number of turns in the coil. See, so if you have 1,000 turns, but you have 3 wires, then you actually have 3,000 turns. And then you have to determine what this coil is going to be used for, especially if you're doing a transformer. In most cases, the drive coils do not make good generator coils in a transformer. because you don't need a lot of turns to run the drive, but you need a lot of turns to generate the electricity. Now, these are 32 gauge coils. They're a little small, but I wanted to pack as much turns as I could into the space. And this coil, well, okay, this coil is a lot better suited to generate than this big one over here. Because it's quickly saturated, it has a soft iron core, and every time the magnet passes, it encompasses the entire coil instead of half of the coil like over here. And I'm talking about the field. I'm talking about the magnetic field that these awesome magnets generate. Encompasses the whole amount of copper here. So every turn you get the max benefit. And like this one here, you'd have to spin it for quite a while to even get the whole thing lit up. An even better coil right here, because it's only that thick, which is half of this, or a little bit more than half. This one, boom, 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 boom. I mean, it's so much, you don't even have to worry about it. And I've noticed that, you know, the shape of your bobbin that you're using to create your coil, whether it be a radial coil or a serpentine coil, you know, any kind of coil, you want to make sure that it's made for the magnets that you have on your rotor. Now, if you're using a Bedini style SG, the magnets don't really matter. Like if you're using this style circuit, this is a Bedini SG generator combo from K Energy store. If you use that, the size of your magnets doesn't matter as long as you can trigger. If you can trigger, you're going to get the full benefit of how much you're putting in. Oh yeah, no, about the meter, I totally, I'm working on that myself, you know, all the time, how to hook it up right, but you know, instead of just changing it all the time, I just decided to run it off the bridge rectifier. I don't know if that's legit, but it's legit to me. It's mathematically, it works out. Yeah, yeah, I should write some of this stuff down. Like this coil spread right here, the 18 gauge, the 20 gauge, and the 32 gauge. I mean, 3 coils just like this, except it was a step down. So it went from like 900 to 600 to 300 turns. I don't know why I did that, but I made, that's what I did. I made the 3 coils using like 369. So this is the tiny one, the 300 one. So I mean, this coil spread is powerful with the 20 gauge as a transformer, and the 18 gauge is the drive, man. It's yeah, 3 times typically. You want to run? Oh, I'm gonna have to go get my daughter here in about 5 minutes. it's been a really good time, guys. I really appreciate this run. I've learned a lot, and you guys have been a really great audience. No, sir. We don't do that here. Sounds like you might know what that is, though. Not much heat that I've seen. And I did invest in one of those that's a shame. And you people let these people own weapons? That is insane. All right, love you guys too, man. Thank you. I really appreciate it. Peace out. Have a good day. Please subscribe.